you can see that, can you see the photo? So this is the helical antenna. So it depends on number of turns that you are going to do your antenna as well. Okay, so what I can see here, this is the design parameter. Okay, the most important thing is your diameter, your circumference, your separations, as well as total length. So you can find it all this value when you know what is the design specification later on. Okay, in terms of the helical antenna, we have two different modes. The first one is broadside. It means that, okay, like this, you can see here. Okay, you can see here. Okay, you can see that we have our normal mode as well as the environment. Normal mode is just like that you have in terms of the antenna for the dipole. So this is in terms of the normal mode. So for dipole, and for the end fire, it means that this mode is coming from at the end of your helical antenna. So that's why they call in terms of end fire modes, or sometimes they call axial modes. So you need to do the different. If the question asks you about the normal mode, make sure that you are using the correct on the normal mode. If you talk about the end fire mode or axial mode, so you have to use the end fire mode or axial mode equations. But I think the question is very similar, so it's not much difference. All right, so this is helical modes that everybody knows, that you know. So it means that this is what we can see the helical modes here. So the most important thing is your diameter, the diameter of your helical, separations of your number of turns. So number of turns depend on what is the questions ask you, whether you want to have the n number of 10, 20 or 10 or 5 or only 3 turn and so on. So this is what we can see that here. This is the normal mode. Okay, so actually the normal mode is a combination from the loops antenna plus a short dipole. So it can become the normal mode. And this is the equation, mathematical expression for E phase, E phi, and E theta here, the field. And then from there you can find the axial ratio here. Okay, and then you also can find the pitch angle here. The pitch angle, as we can see from the notes, you can see that the pitch angle is what is the difference between this one. You can see pitch angle is alpha, so you can get from tangent alpha into S over C, or your sine alpha is equal to L naught over C over L naught also. So it doesn't matter which one, because from this particular value for the C1, you can get in terms of from the theorem Pythagoras here. Okay, so this is this is what we can see here. You see, so this is your pitch angle here. So this is alpha pitch angle. This is your S separation. This is the total length of this is your circumference. And circumference is just, you can see that C is to pi, the D is the diameter of your helical antenna here. So you can find it in terms of all these values. So what you can see here, we have two cases, because as I told you before just now, for the normal mode is a combination from loops as well as dipole. So we have a special case when your alpha is to 0, when your separation is to 0, so it becomes a loop antenna. When alpha is a 90 degrees, it become, there is a D is to 0, so it become the linear antenna, or what we can say there is a dipole antenna here. Okay, so this is the equations that we can use in terms of alpha. L naught is the length of your antenna, S is the separation, C is your circumference. If you have a number of turns, total length is N multiplied by your L naught. So yeah. So what can say that alpha is to 0, the spacing is 0, this antenna become loop. Alpha is to 93, the spacing become infinite, the antenna become monopole antenna or linear antenna. If 0 less than lambda, so this antenna is helical. So it means that if you want to use as helical antenna, you have to make sure that the pitch angle is between 0 to 90 degrees. You can see that it's different from the axial, for axial mode or end fire mode, because your angle, the pitch angle must be between 12 and 14 degrees only. Okay, so this is what you can see, axial ratio that you can find, and you can find the of C as well here. Okay, if you talk about the axial beam or mode operations here, we can see that, okay, the alpha should be between these, because just now the alpha is from 0, alpha 90, but this one is from 12, alpha 14. So a bit more small in terms of this degree, and then S is usually is lambda over 4 here. So for the end fire modes, what we have to do, we need to know that your alpha is between these. So if you want to differentiate between the normal mode and so the alpha is 0, less than alpha, less than 90 degrees. Okay, so the near optimum circumference here is C is equal to pi d here. But in this case, C is equal to lambda naught, is equal to operating frequency. And N should be greater than 3. N is the number of turns. So your R resistance here, the HPBW from the N fire modes, you can find as well. And then first null be with dimensions as well as the axial ratio here. So what you can see that the axial ratio to determine whether your antenna is a circular polarizations or not. Okay, so this is about the field design, how you want to, and then we need, if what happen if you put in terms of axial mode helical antenna with the ground plane here, okay, and then in terms of the conductor size, okay, radiation pattern for the axial mode, and the normal mode helical antenna here, small dipole. Okay, normal mode for the small dipole, small loop, therefore you can find them all. So what you can see that all this value is similar than what we have before. Okay, so this is your design about this normal mode helical antenna here, and then on small circular ground here. So it depends on you how you want to design the antenna itself. So this is some of the specifications that you can get it from here. And then this one they just make in terms of the effect of ground plane and etc.